Okay, so there is a request to explain the row equivalent form and row reduced row equivalent form. So we will briefly recall the idea. So far we have discussed, just to recall, system of linear equations. We have studied how to find the solution, and we have seen that if we do the Gaussian elimination, then we will get the uh, row echelon form. And if we do Gauss Jordan elimination, then we will get reduced row echelon form. So whatever the process we do, we have seen how to find one unique solution. I mean, if you want to find many solution and no solution, all the three cases, so this can be obtained via these two elimination process, either one of them. That means given a system Ax equals to b, you try to reduce after row operations. You have to reduce it and find it A transpose X, not A transpose, A prime X sum B prime. So this A and A prime are row equivalent. If you remember the definition of row equivalent, if the matrix A prime is obtained by a finite number of elementary row operations from A, then we call it a row equivalent matrix. Now the solution of this system are exactly the solution of this system. So why we do this row operation? Because we want to simplify this system in terms of a row equivalent system. So the solution of this system will be the solution of this system. Okay. Now just to recall, what is a row echelon form? Row echelon form will have three possible structure. Whatever we have, either this one is this can be 1, this can be 2 also. So that is why we are not putting anything else. And the other entries will be of this form. So property 1 says if all zeros, if a matrix has a 0 row, so it will be on the bottom, at the bottom of the matrix. If at all the 0 rows will be at the bottom. So here 2 0 rows are there. So this is a structure first, or it can also be like this. We have only 1 0 row and others all are non-zero. Maybe it cannot, it may not have any 0 row. So in that case, we will have this form. So it can start with 0 also. So there is no harm, because it says only two properties. First one is a 0 row will be at the bottom. Second one is each leading non-zero entry, this black squares that we are seeing, these are non-zero entries. This can be 0, this can be non-zero also. Okay, so that is why we have put the star asterisk signature, asterisk symbol, and every time we will have the each leading non-zero entry will be the right. This is right, and this is left. Right of the previous leading non-zero entry. So previously we have non-zero entry here. The next is leading non-zero here. Similarly, the right and then left Similarly, all these cases will be there. Okay. Now, reduced row echelon form is more specialized case of this row echelon form. What we have in this case, reduced row echelon form, instead of arbitrary leading non-zero row, here we are telling just a non-zero. 1 is also non-zero. Okay, 1 is not equal to 0. So all these black points that we are having, black square points. So in place of arbitrary non-zero rows or arbitrary non-zero numbers, we have 1 as a leading non-zero. It has also another property that if any column has a leading non-zero as a 1, except 1, all other entries in that particular column will be 0. So if in this case there is no leading non-zero in this column, so in this column also no leading non-zero, so all are zeros. It can also be like of this form. But if we have another non-zero row, so it will satisfy the left-right property. It will always satisfy the right and left property for the leading non-zero entry, and then it will satisfy the this pivot. Each pivot leading non-zero will be equal to 1. So here it is 1. Leading non-zero is 1. Except 1, all other entries in that particular column will be 0. Okay. Now, if you remember, so for example, a given matrix A, you are trying to find out by row operations. Row operation, we have seen that elementary row operation E1, E2, and E3. Elementary row operations. Whatever you do, for example, if you do E2 first and then E1 and then E3, this ordering of this row operation do not matter. You will get this unique matrix. Whatever order you follow, either E1, E2, E3 or E3, E2, E1, you will end up, finally, you will end up with the same reduced row echelon form. So that's what this theorem says. Okay, next. So if you think about a 2 by 2 example, 2 by 2 matrix. So if you try to find out, so this is to find RR EF. Why it is more important to find out RR EF? Because it also includes the REF. If we find RR EF, it will automatically give us the REF in the finding this process. So it will automatically give us this REF. Okay. Now, what we need to find REF? So every time we need to get 1 here. So for that, what we do? Either you can divide. One thing we can divide also. If you do here also this R1, 1 by 3 also, then it will be 1 by 4 by 3. So that is also one way to get the 1 here. Okay. But we have another row operation. If we can exchange, then also it is possible. And then once we get 1 here, we want 0 here. So we want a -3. So that is why we have done this. So row 2 is replaced with this operation. Okay. So in this way, we will try to find out. I mean, this concepts will be clear if you practice more and more. Okay. And similarly, once this is 1, 0 is happened, this first column is taken care, then we have to go to the second. So we want 1 here again, then we will divide by 10. So divide by 10. So it becomes 1. Now we want 0 here. So that is why we have been doing the row operation again. So this is our row echelon form of the array. So what we do here is we have taken the augmented form. Now this system is actually equivalent to first the system is 3x1 plus 4x2 equals to 1, and then x1 minus 2x2 equals to 7. So this is our given system. What we are doing? We are actually x1 plus 0x2 equals to 3, and 0x1 plus 0x2, sorry, no, minus 2x plus x2 equals to minus 2. So this is our after row operations. So we do some row operations and we reduce the given system into a simplified one. So from here we can read the solution directly. So x1 is 3 and x2 is minus 2. So this is how we actually do for 2 by 2 system. Okay, for 2 by 2 system, what we do, we can do some multiplication multipliers, and then we eliminate x1 variable, and then so that is also one way, but this is another approach to find out the solution of the system. So the target is to reduce the given system into a simplified one, a row equivalent form. Okay. Similarly, if you get the 3 by 3 system, then it will look like in the same way we can find out the solution. So that's what the use of RREF to find out the solution of a system of linear equations. Now the question is where we can find the application of these systems. So applications are actually several real life examples can be seen. For example, cryptography you can see in the rocket science, you can see electric circuit. Also you can find it in a chemical equations also. So we'll see some. So what we have for the main target is to get, okay. So in the last lecture we have seen how do we get the unique solution. Okay, in the last class we have seen that. Even these two examples also, this is also a unique solution. Here also we have unique solution. So what happens? We try to get the real problem, then we make it into a mathematical model, and we solve this mathematical model. After finding these solutions, we will analyze and we have to interpret the mathematical solution into the real life problem solution. Okay. So this will be, you can understand this structure or the relation if we have a practical example. For this is electric network. For electrical network, we may have some point rule and loop rule. There will be current passing through the circuit, and how much we have to think about it. So you can see here, what will be the variables I1, I2, and I3, that circuit. Okay, so we can get a system. So this is overall more or generalized system, R1, R2, R3. So E, R1 and R2, if these values are given, R1, R2 and R3, also E is given. Once it is given, so you can find out I1, I2 and I3. What are these? So the amount of electric passing through these points I1, this can be I2, and this, if you think about this, I3. So you have to find out these unknowns I1, I2, and I3. So if you have this as a system, so you can find it as it is 1, -1, and -1. Then 10, 20, 0, 0, 20, -10. And you can find that augmented matrix. This is 0, 12, and 0. Now you try to find out the REF or RREF. And you can get the solutions. Okay. So this is a real world problem. You make it a mathematical problem. In terms of equations, you are writing it mathematical problem. Now you get the solution, mathematical solutions. Okay, so from here you will find out the I1 value, I2 and I3 values of I3. So what could be the values of I1, I2 and I3 so that there is no problem in the system. Okay, so in this way we can find some similar applications. If we have how to balance, if we have a problem, how to balance a chemical equation. So there is a balance the chemical equation. This is a problem. Okay. Then you have to find out the unknowns x1, x2, and x3, and x4. So what are these? The amount of C2H2, x1 is the amount of C2H2, so C2H4, H6. Then x2 is the amount of oxygen, x3 is the amount of CO2, and x4 is the amount of H2O. So for carbon, you have to find out how much you need. So this equation is equivalent to writing of this form. Similarly, hydrogen molecules will be, the left hand side molecule and the right hand side molecules, whatever the conditions are there for a chemical equations. So you have to satisfy those equations. Okay, and oxygen's level will also be equated. They should follow the chemical equations. And then you can find the applications here. So here you write the augmented matrix. And then you try to do the row operations. Finally, you get the RREF. So from here, you can get the solutions. What will be the solution? Now, this system will be can be written as of this form. So x1 minus 1 by 3 x4 equals to 0. x2 minus 7 by 6 x4 equals to 0, and x3 minus 2 by 3 x4 equals to 0. Or you can write it directly from here. x1 equals to this, x2 equals to this, and x3 equals to this. So these variables are dependent on x4. So what we can say that, for example, if you take, since x4, all the variables are in terms of x4, so if you take, you can write it as a parametric form. For x4 equals to 1, this will be 1 by 3, then this will be 7 by 6, and this will be 2 by 3. We'll take this simple values. When we have this kind of situations, so we'll have this kind of solutions that there will be. For x4 equals to, if you take x4 equals to 2, then you will get different values. So in fact, depending on the structure, the solution equations that you get, the terms, that is final equations. So here, in fact, you will get an infinite number of solutions. So why such equations? So why we are getting such infinite number of solutions, that we'll discuss a little bit later. But first, we see another example. So if you have a problem where you want to decide the upward velocity of a rocket, then for example, if you want to get the velocity of these rockets, for this is v1, this is v2, or you can have this v3. Okay, then how to fit this data that is given in this table. Depending on this table, you have to some t1, different times are given, and different velocities you have to find out. So which velocity should be preferable to eject the rocket, so that you can decide. So for that you have to for example, you have to approximate the, so don't get tensed. What is the approximation? You just take that this is a velocity, the equation of a velocity follows this pattern. Okay, you don't have to worry about it, because this is a more kind of numerical analysis. Maybe you will study it in a fourth semester, or if not fourth, then you can study it in the third semester. Okay, so for t1 we have this velocity as this part. For t2 we have this. So this table says, okay, t1, t2, t3. So depending on that, you will get 3 equations and then 3 variables. So this system will be actually of this form. Now from here you can get a system of linear equations of this form and try to solve these equations of this form. Now if you try to do these row operations, take the augmented matrix and do row operations. Okay, then you will get some and then augmented matrix. So from there you can get the solutions. So you can see this is either in terms of REF or RREF. Okay, your main idea is to find out this RREF. So we have seen some, in fact, these few examples are saying that why we need matrix algebra to understand the real life engineering problems or some other problems. Now you can find in your field similar examples. Okay, just try to think. Okay, just to recall, the solution of a linear system. So here we will have unique solution. Okay, so this is kind of RREF. So here the rank.
One student is waiting in waiting room, sir. Please allow him.
Okay, I have not seen. Actually, when I'm writing on that slide or PPT, I'm not able to see. So thank you for informing. Today I'm getting, okay, right. So rank of this matrix, let us call, so from here, let us write as augment A is the matrix, this one, 2, 8, 4, then 2, 5, 1, and then 4, 10, and minus 1. Okay. Let us write A bar A B, or we can write A B. No, not in this way. Augmented matrix A B. A suffix B. Okay, so this will be 2, 8, and 4. Okay, and then we have 2, 5, 1, 4, 10, minus 1. Then this is 2, 5, 1. So this we call augmented matrix. So what is augmented? If you if you find the dictionary meaning of augmented means whatever the given quantity, you just make it larger. Augmentation, that is mean. Now, if you think about the augmented, what is the rank of AB? It is in the REF, for example.
3.
It will be 3,
3.
right?
3.
And how about the rank of A?
3.
3.
3. 3.
Only A? Yeah, this is also 3. Okay. So if we have these situations, okay, then we say the system is consistent. If you remember, consistent, a system is said to be consistent system if it has at least one solution. Let me just recall. If it has at least one solution. Okay. Now that we know the rank of an augmented matrix and rank of the given matrix, the coefficient matrix, okay, if they are equal, then also we say the system is consistent. Okay. It has at least one solution, or the rank of these two matrices are equal. Okay, right. So let us understand the case of many solutions. When do we have the case of many solutions? So for example, if we have a system of linear equations of this form, try to find out the augmented matrix and do the row operations. So let us, okay, for graphically, as you know, that if we have many solutions, that means all the three planes will intersect in a line. We will have a line of intersection. For unique solution, we have seen there is a point of intersection. So this augmented matrix, what is the rank? It is 2.
2.
What is the rank of A?
2.
So this is also
2.
2. So as these two are equal, so the system is
consistent.
so the system is consistent. Okay, but we have not answered how many solutions are there. How many solutions? That we have to see. So let us take the this equations. Okay. So 1 plus x3 equals to 2. x1 plus x3 equals to 2. Then x2 minus x3 equals to minus 3. x2 minus x3 equals to minus 3. So from this last matrix, we have this system. Actually, this was a 3 by 3 system. Now we have reduced it into a only two equations are we have seen that independent. Okay, so that is why we can find of this form. So there you have you can write it in terms of x1 will be 2 minus x3 and x2 will be 2, or you can write it at minus 3 plus x3. So this is arbitrary. Okay, we can if we want numerical values for numerical values solutions, we have to assume some values of x3. So for x3 equals to 0, we have x1 equals to 2 and x2 equals to minus 3. In that case, the solution solution of the system will be 2 minus 3 and 0. So if you take x1 equals to, sorry, x3 equals to, it is dependent on x3. So x3 will be 1. Then you will have x1 equals to, in fact, if you want to write the general form of the solution of the system, it can be written as x equals to, this is 2 minus x3 minus 3 plus x3 and x3. Okay, for different values of x3, we have different solutions. In fact, we have infinite number of choice of x3. So that is why we get here many solutions. Okay, now look, let's just go back and check what happened here. So this is a 3 by 3 system. So the maximum rank can be maximum rank of A can be 3, right? This is 3. But we have seen after row operations, this system has reduced to a rank of 2. So we will conclude. Just remember these equations. and then we'll try to find out that. Now there could be a question that why we are writing x3, sorry, x1 and x2 in terms of x3. Can we write x1 and x2? I mean, other way also. For example, if you write, if you try to write some different, for example, from here you write x3 equals to 2 minus x1, and then you will get x2 equals to, from here also x3 equals to minus x3 equals to minus 3 minus x2, or if you just write it plus, then plus. Okay, in this form. So can it be taken as a solution? Okay, of course, but we do not write in this form. So that means you will make these two equal, since this is x3 and this is also x3. So this will give you the relation between x1 and x2. So 2 minus x1 equals to 3 plus x2. So that means you are getting another equation. I mean, ultimately, you are not getting the solution. Okay, so x1 plus x2. Let us take, here it is. So this becoming minus 1. So we are not getting the solution in this case. Again, we are getting one equation. Okay. So we have to choose which variable should be on the right hand side. Okay. So that is why we have to introduce the concept of two new definitions. One is called basic variable.
Sir, the equation in x1 and x2 represents the line of intersection, right? Of the
Yes,
planes.
yes.
Okay.
In fact, this solution, okay, this particular solution will be the points on this line of intersection. Okay. Are you able to relate to this function? Whatever you
Yes.
say, whatever you asked, is actually the points that is here. Yeah, in this line. The solution points are here in this. So a line has infinite number of solutions, as you know. So here also you can see that there are infinite number of solutions. Okay, and geometrically you also see that the intersection is a line of intersection. It is not a particular single point. So you have here a line of intersection. So try to relate these two facts from geometry and algebra also. Yeah, it is. Now the question is that, like I said, that we have to introduce, if we have a situation of this form for a different system, okay, if we have this is the reduced or row reduced equivalent form, REF, okay, then what we want to try, we want to find out the solution of this problem. So this is a we have four unknowns. This is x1, x2, x3 and x4, and this is the right hand side vector. Okay, x4. Now this system, we can write it as, after row operation, it has been reduced to of this form, and we can write it in this form. Now when we have this kind of situations, okay, we can write as a vector form. So this is a vector form. The solution can be written as a vector form, okay, and the generalized form is of this type. For a different choice of x3 and x4, we have different solutions. So here also many solutions. Or to be specific, here we have infinite number of solutions. Now, if you look at the rank of the augmented matrix, it is 2. Here also rank of the coefficient matrix is also 2. But it can have at least maximum of 3 also. It can go maximum of 3. Okay. So there is a feeling that whether this number of solutions is anyhow is connected to the concept of rank, whether it is dependent on the rank. The answer is yes. So let us see one more example where we can. Okay, let me just tell you that who will be the on the left hand side, and who are the variables, which are the variables that will be written as in terms of y. So this particular variables will be called basic variables, and these are called non-basic. These two are definitions actually. What are this importance? Because if you try to write x3 and x3 and x4 in terms of x1 and x2, then you may not get of this kind of solution. Our aim is to find out the solution, but if you write in this form, then you may not be able to get the actual structure of the solution. So for that, we have to define, we have to understand who are the basic variables and which are the non-basic variables. So for this, we have two rules. We will define the pivot position. What is a pivot position? A position of a leading entry in an echelon form of the matrix. So this is a pivot position. Here it is pivot position. So if this is the if we have a pivot position, then we call it a pivot column. This column will be a pivot column. So from here, if you do the row operations, then you will get. Okay, possible pivots are here. And then what is a pivot? A non-zero number that is either is used in a pivot, or a pivot element, you can say just the non-zero, first non-zero entry, that is non-zero leading entry. In this case, we have non-zero leading entry is 1. It can be other numbers also. Okay. So leading non-zero number is called pivot. And that particular column is called pivot column. This column will be pivot. Now we have to find out who are the variables, which are the variables. So basic variables are those, any variable that corresponds to a pivot column in the augmented matrix of a system. And free variables means we have seen that we can take the values of x3 and x4, anything. So that if we take different values of x3 and x4, then we get different solutions. Like we have seen here for this example. If you take x3 equals to 1, 2, and all, so you are free to choose any variable, any value for x3. So in that case, we have such situation. So many solutions. Okay. Now, these definitions are for how to choose your basic variable and non-basic variable. That means basic variable and some free variable. These are called non-basic variables. So if this is a system of equation. So this is x1, x2, x3, x4, and x5. So this is augmented matrix for a given system. Now you want to find out the pivot positions. So these are the pivot positions here, here, and here. So basic variables, you can say x1, this is the first column. Then we have x3, and we have x5. And free variables or non-basic variables are these two, other two, x2 and x4. Okay. So from here you will get the values of x1 in terms of x2 and x4, values of x3 in terms of x4, and values of x5 it is just directly given 7. So the solution will become of this form. Okay, x1 is actually of this form, minus 6x2 minus 3x4, then x2, then x3 becomes 8x4, and then x4, and then x5 is 7. Okay, so for this particular system of linear equation, we will have this solution. So these are free variables. You are free to choose them, and these are the basic variables. Depending on this, you will get these values. Okay. So that's what for a case of many solutions. Now we have inconsistent solution. That means no solution.
Sir,
Just tell me.
sir, once go 3 slides back, please. Ah,
Yeah.
here, this one. No, previous one, sir.
This one?
One more. Ah, this one, sir.
Okay, tell me. Okay, any doubt?
Understood, sir. Thank you.
Okay, right. Okay, now before I conclude all the cases, let us just quickly understand the case of inconsistent system where there is no solutions. So if we have a system of linear equations of this form, we have two variables and 3 equations. Okay. And we try to find the augmented matrix, this reduced matrix, the rank of AB. What is it?
3.
How about rank of the coefficient matrix?
2.
2.
It is 2. So when they are not equal, okay, rank of A not equals to rank of AB, then we call it a inconsistent system. That means we do not have a solution. So this is a very important remark. In the inconsistent system, if you have a generalized system, M linear equations, here it is 3, here M equals to 3, and N equals to 2. And in two variables, N variables, will always give us a situation where in the reduced row echelon form of the augmented matrix, in which the first n entries are 0 and the n plus 1th entry will be non-zero. So this part it is talking about this particular. So if you write of this equation, so this will be 0x1 plus 0x2 equals to 16. So it is giving us a situation 0 equals to 16. So which is not true. Mathematically it is impossible. 0 equals to 16. So that is why we have an inconsistent system. We have impossible event. Okay, so for this type of situations, we do not have any solution. Now, if you just try to sum up all the cases, So these are your practice problem. Try to solve them. Let me just quickly summarize. If we have a system of linear equations, we try to write the augmented matrix AB. From here we will get A matrix. Okay, and we will try to find out the elimination process. We'll do the elimination process. Either you use the Gaussian elimination or you use the Gauss-Jordan elimination. That means you want to try to find out rho equivalent for REF, or you find out RREF. Either one of them, and then the procedure you can see. This is how we do. Let us just conclude. Summary will be of this form. So if this is a non-homogeneous case, that means the right hand side is non-zero. It can have either consistent or it can have inconsistent. Okay. So if you just recall this system, the rank of AB, the augmented matrix, is 3, and the rank of A is 2 here. So 2 is less than 3. So there we do not have any solution. But if we have the rank all are equal, both of them are equal, then what we have, either we have unique solution, like we have seen in this case, the first case that we have discussed in the last class, or we may have this kind of situation where we have n minus r arbitrary parameters. That means free variables. Okay. Here n is the number of variables and r is the rank. Here r equals to 2 and n equals to 3. The rank of matrix. So here we have, sorry, let me just rewrite. The rank of A is less than n. What is n? N is the number of variables or number of, you can say this is the maximum infinite solution case. Yeah. Here. R is the rank of A. Because this is the case where both of the rank of A and rank of AB are equal. So we'll write it in terms of rank of A. R is the rank of A. So that means we have four variables, x1, x2, x3 and x4, but we are having only 2 non-zero rows in the augmented matrix. So that means 2 variables are free variables. So n minus n is 4 and rank is 2. So 4 minus 2. Okay, 2 variables are free variables. So this is all the case that we have.
Sir,
Yes, tell me.
please once again explain the concept of basic radicals and free radicals.
Okay, free variable and basic variable.
Sorry. Variable.
Okay, right. Let me just let us come to this point.
Sir,
Just tell me.
go to the previous slide, sir. You explained it before.
Yes, I have done that. This one.
This one, sir. Explain with this one.
Okay, sir. Let me take this case. Okay. So here, if you try to write this case, okay, here we have, as you know, that this is x1, x2 row, x3, and x4. We have 4 variables and 3 equations given. We have the, for a given system, we have the RREF. Okay. If we have this kind of situation, okay, then you try to write down the equations. This is rho equivalent to the given system. What it will be? X1 plus x3 plus x4. Now try to find out the pivot positions. What are the pivot positions? These two are pivot positions, right? Pivot elements. Okay, and they corresponds to the column, the first column and the second column. Okay. Now the equations becomes 3 and then it becomes x2 plus 2x4 equals to 1. Now if you think that we can find out the solution in terms of x4 and x3, then what will happen? Okay, so try to write it. X4 equals to 2x4 equals to 1 minus x2 and x4 equals to 1 minus x2 divided by 2. Okay, so from here, and if you substitute this value in this previous equation, then you will get x1 plus x3 plus x4 is equals to 1 minus x2 divided by 2 equals to right hand side is 3. So just to simplify it, 2x1 plus 2x3 plus 1 minus x3 equals to 3 or not equals to 6. So what you get now is x1, 2x1 plus 2x3. Let us take this one in the right hand side. So 2x3 minus x3. Sorry, this is x2.
Sir,
Not
the,
x3.
x1, x2.
Yeah, this is x2 minus x2 equals to 5. Okay, so what you are getting now, we are able to find out x4 and we are not able to get other variables, right? So if you try to write this form in the vector form, x1, x2, x3 and x4, right? X4. So what you have to write is, for example, you write x1, you write x3, x2, and then you write x3, and x4 you write 1 minus x2 divided by 2. So if you write it in this form, then you have to assume 3 variables. x1 will be unknown, x2 will be unknown, and x3 will be also unknown. If you try to write in this form. But it is sufficient to get, there also you will get infinite number of solutions. Okay, infinite number of solutions. But the actual case, so this is a not a preferable method, because here you have to assume three arbitrary values, x1, x2 and x3. But if you go here we are just two arbitrary values are sufficient to get the solutions. That is why the concept of basic variable and free variables are actually introduced. You have to identify which are the basic variable and which are the free variables. So basic variables are those which are related to the pivot elements, pivot column. So this is column number 1, column number 2. So that is why x1 and x2 are basic variables here. And other two variables are free variables.
Sir,
Is that all right? You
sir,
get the idea?
how have you concluded that they have infinite solutions?
Yeah, you have infinite number of choice. They are arbitrary. That means if you take x3 equals to 0, x4 equals to 0, then the solution becomes of this form. If you take 1, if you take 0, then you will get another solution. If you take 1 and 1, then you will get. So how many possible choice you can have? You have infinite number of choice. See, it is saying they are free variables. That means you can choose any variable. You can say negative also, -3, -2. Whatever you choose will become a solution for this particular case, because it is not having the full rank. So for this matrix, what will be the full rank? We have 4 columns and 3 rows. So the maximum rank can be 3. But it is not happening here. We have rank is 2. Rank is 2 less than 3. So whenever we have this situation, okay, rank of the augmented matrix, rank of the matrix is less than the full rank, then we have this situation, infinite number. Are we clear now? If you have any doubt, please try to think.
Sir, hello.
Yeah.
Sir, if you take x3 1, x4 also 1, then you get a whole new matrix, no, sir, after adding those three.
Which one?
x3 1, x4 also 1.
x3 1 and
x4 also 1.
yeah, let us take it, no problem. This is also 1, this is also 1, right?
Yes, sir.
So let us put 1, 1, 1, 1, 1 and 1. So this will be -2 plus 3. So this is going to be 1. So -2 plus 1. This is going to be -1. So 1, 1, 1 and 1. Whether it is a solution, just verify it. Okay, so the system I have not shown. I wanted to explain the concept of free variables. Okay. Whether this will satisfy these equations, try it. 1, x3 is 1, x4 is also 1. So 1 plus 1 plus 1. So this is 3. Satisfied.
Yes, sir.
Okay, so this is 1. And this is also 2 times 1. So sorry, x2 is -1. So this is -1 and 2. So 2 minus 1 is 1. Now if you try some different values, okay, for example, in place of free variable, for example, if you try 0 and 1, so you will get 2. So then again it is minus 1. So 0 and then 1. Okay. So in that case, x2 is equals to 2 plus x3 we have taken 0 plus x4 we have taken 3. So 2 plus 3 is 3. Left hand side, right hand side equal. For this case, it will be -1 and then +2. So this is again 1. Okay. The solution means it will satisfy the equations. The original equation has been reduced to this system. Okay. Whatever the solution of the original system is equal to will be the solution of this reduced system, because they are row equivalent matrices. So this is how the ideas are connected to each other. So we are having infinite number of solutions. I think now you have understood the concept, how we are getting many solutions.
Yes, sir. Yes, sir. Thank you.
Okay. So if you have any more doubt, or I have given some 3 examples, 3 practice problem. Try to find out whether we have, this is a possible, I would say, verify.
Where do we get these PPTs, sir? In student portal, right?
Tell me.
I'm asking that we get the practice problems like in PPTs, sir.